Okay, I will introduce the next presenter. Our next talk will be by Filip Hráček from Google. This will be the final talk before our rather experimental lunch. Filip works at Google as a developer relations program manager. And in his work, he tries to connect Czech developers with the recent advancement of Google technologies by doing several workshops and public talks. In his talk, he will talk about the Google tools for working with big data and really how Google tools and technologies can make big data manageable. So, Filip, the floor is yours.
Okay, can you hear me now? Nice. Thanks for introducing me. Thanks for having me. As has been said, my name is Filip Hráček. I work for Czech Google office, and I'm mostly talking to developers, but I'm also kind of a data geek, so to speak. So I think I'll have some nice tools for you that are mostly from Google that you can use. I'm pretty sure that, or I suppose that many of you know some of the tools that I'll be talking about. And I know for a fact that some of you know many of the tools that I'll be talking about. But I still think that there will be, for everyone, some new tools that you probably haven't seen yet. So let me start with something that you already know. Big data is hard. Friedrich actually said that a while ago. Big data is hard in so many levels. The gathering of the data is hard. There's a lot of data. It's really very hard to get normal data, like a table of 500 rows. It's so much harder to get a table from someone of 5 million rows of data. Then there's the refinement. It's a nuisance, or it's really inconvenient to refine, to clean data that has 500 rows. It's almost impossible to clean data that has 5 million rows. Then there's data analysis. Data analysis is hard with any data. With big data, it's super hard, because now you have 5 million rows, or maybe 150 million rows, and you want to analyze that and see what's in there. And that's hard. And last but not least, it's really hard to share big data, because it's just so big that you can just send someone a CSV with 20 gigabytes of data and say, hey, have a look at this. It's interesting. It doesn't work. You have to do something differently. So let's look at this. Data gathering. The primary data, I don't think any tool from Google or any other company can help you with. This is what you do. You talk to governments, right? And you get the data yourselves. But there's another type of data that you need, and that's the secondary data. If you have primary data, a huge database from the government, in itself, it doesn't really tell you much. It tells you something when you merge the data, or when you show the data against some other data, some secondary data. You want to make comparisons. You want to provide context. You want to provide trends. And for that, there is a couple of tools, actually. One of them that I want to show you is Public Data Explorer. Who here has been to Public Data Explorer yet? Okay, not many of you? Cool. Public Data Explorer, this is the page this is the data that are available for Czech. I'll just switch to English. So there's just data from all different sources. And the good thing about this is that you can really explore them. So I just click on this graph. It gives me nice visualizations of the data that are publicly provided. I can look at it, I can slice it and dice it, I can look at it in different ways. So it's really easy to get the feel of what the data are about, to get some first impressions on what I should be looking at, and then maybe merge it with the data that I have and use that, right? Again, you might be thinking, well, the data that you're showing, they're already there, so it's not a big deal, right? They already are somewhere. This is just the gathering of these data into one page. So let me show you. Okay, so this is another kind of thing. This is the unemployment rate in Europe from Eurostat. If I click, there's always a link here to the source of the data. If I click on that, I don't know how many of you have been to this site. I guess many of you, but this is the actual source of the data. First of all, if you've never been here, you have no idea where the data actually is. Second of all, you don't know if it's interesting or not until you download it, right? So you go to database here, you look at this, you unclick this, you have to download all this stuff, then put together, or it's really, really hard to get this and to actually analyze it. And you can easily spend hours just getting this to your computer and looking at graphs. And so this is the thing that Public Data Explorer tries to solve for you. So that's that. And then if you're really interested in the data and if you want to slice it in other ways, or if you want to merge it into your own data, then you're free to do that. Another nice thing is FusionTables. FusionTables are something that I'll be talking about later on. They're just a way to publish your big data on the internet and have that available publicly if you want. You can play with the tables, you can visualize them, and so on and so on. The good thing is that people are already using it a lot. And if I go to this link, I can search for FusionTables that are available right now, like we were talking about fishery, I think. So there are 2,100 tables, most of them not really very informative, but some of them really, really good about just fishery, right? So this is a lot of data that you can use. And again, it's not the primary data for you probably, but that's something that you can merge with the other data. There's a nice thing called Google Trends where you can see how different search queries have been searched for on Google for different geographies, for example. It's nice to see trends again and to see the context of what's going on. What's more interesting, I think, is Google Trends Correlate. So in Google Trends, you say, I want to know this query, like ODS, the political party here. How was it searched for during the years from 2005 to 2012? And it gives you that information. Google Trends Correlate is you have a graph, and you want to know which query correlates with that graph. So let me show you how that works. If I have a graph of some activity during time, I can upload that CSV into Google Correlate. It will tell me what kind of queries correlate with that kind of graph. There are some predefined graphs. So, for example, this is the pattern of actual flu activity from the health organizations in US. And when I upload that information into Google Correlate, it'll tell me what people are searching for that correlates with this graph. And so in retrospect, of course, that makes sense, right? 0.9 correlation influenza type A. So this is the actual data. This is the red line is how people are searching for influenza type A in the US. Right? Very interesting if you have any temporal information. You can do. Actually, let's have a tipping contest. What do you think will happen when I shift the series? So I can see what correlates 1 week after there is increased flu activity, I guess, or more. So what comes after that? Any tips? I'll give you just 5 seconds to think about it yourself. It's really obvious in retrospect. If I shift it 1 week later, it's flu duration, right? So we're talking about people who have had flu for more than a week. They want to know what's the average duration of flu. Also, there are people who have seen a lot of other people having flu. So they wonder how flu is contagious, and so on and so on. And again, you can flu or cold. And you can, of course, you can download the data in CSV format and so on and so on. So that's nice. That's something that will provide, again, some context. I'll skip this. This is really cool, but I don't think we have time for that. Data refinement. So you have a lot of data. Again, big data, so a couple of million of rows. You want to make something interesting out of it, but the raw data is not really usable. There's OpenRefine, formerly known as Google Refine. It's now an open project that you download to your computer. You get the data into it, and it allows you to really easily clean the data, even if it's really, really big. So I have a video that I'll just play 2 minutes of, because I think it's better explained that way. So, can I have the audio out? Yeah, good.
So you're looking at some data journalism project like ProPublica's Dollars for Docs and say, wow, that's cool. They're putting together data from 7 different drug companies in order to discover which drug company paid which doctor to recommend their drugs. Nice. So you decide to dig up some public data yourself to do some data journalism on important social issues. Like, let's say you go to that government's IT dashboard and get data about projects that the government has contracted out to private companies. Download and open it in a spreadsheet program and check out the type of contract column. Firm fixed price. What could that possibly mean? But whatever it means, FFP probably means the same thing. Time and materials. T&M. Wouldn't those be the same as well? And should there be an S here or not? You would quickly discover that public, free, open data can be inconsistent and messy. Think of it as raw materials that you have to refine before it's useful. And that's where Google Refine comes in. It's a free power tool for working with messy data. So let's load that same data into Google Refine and look at the type of contract column again. One core feature of Refine is the text facet. When created from a column, the text facet groups together identical cells into that column across rows and shows you the number of rows in each group. For example, 512 rows contain FFP in their type of contract cells. Clicking on FFP inside the text facet filters the data table on the right to show only those 512 rows out of 5,200 rows in total. Now there are 2 other groups that look like FFP as well. Clicking Edit on the first one shows us that it has a trailing space. Removing that space would merge it into the first group and increase the count to 513. By condensing all 5,200 rows into 800-something groups, Refine makes it easier to locate these inconsistencies. In fact, if we suspect that there are trailing white space in other groups as well, we could apply a trimming transformation on the whole column to fix that whole family of problem in one shot. And now we're down to 785 groups. We could even rename FFP to Firm Fixed Price. That performed a find and replace operation on 513 cells. And we can also change T&M to time and materials, and so forth. You can sort the groups in the facet by count to find the biggest groups. Firm Fixed Price is the biggest group, consisting of 800-something rows. But it would have been even bigger if its many alternative forms were written the same way. Time and materials has the very same inconsistency problem. Google Refine has a clustering feature that helps you fix this family of problem. Essentially, the clustering feature tries to group the groups based on some heuristics. And you can pick different heuristics to adjust how aggressive the feature works. Select any...
Okay, so I'll stop that there, but you get the idea. There's a lot of stuff and a lot of tools that help you clean the data as you see that there. Now let's go to data analysis. Okay, analysis, as I said, is really hard. It's extremely hard when you're talking about big data. And we're talking big data like, for example, this table here. This is all the childbirths in the US from 1969 to 2008, all the official births that have been there with actually a lot of data. So that's a lot of rows. This file is really big. It took, in this pretty efficient text editor, it took 5 minutes to just open it. I could scroll down for ages. So this thing here, I don't know if you see this. This is the line number, right? So I'll go to the very bottom. This is the line number in the really bottom of the screen. So it's a lot of data. And definitely you can slice it and dice it, and you can analyze it in a text editor. So what can you do? So no text editor. Can you upload it to Excel? No. That's probably gonna, explode the computer that you're working on. So what other options are there? Probably a local database. A local database is fine, but there's something I lied to you about. This table that I showed you is just 1/20th of the actual table that has all the births. So what I showed you was just 6 million births, while there were around 140 million births in the US in the last couple of decades, right? And I did some tests in a local database. If you just play with this small table, it takes ages to load, it takes ages to just count. If you would just want to count the number of births in this database for the whole database, it would take 2 minutes. So you just stand there like looking at a screen that just counts the number. And we're not even talking about analyzing anything. We're just talking about counting. So what can you do? Well, there's Google BigQuery. BigQuery is a tool that helps you just with that. It's designed for getting a lot of data and slicing and dicing it. Here's the table, so that you trust me. There's 137 million rows. The whole table is 22 gigabytes, and let's look at how that works. So this is gonna be a bit technical, but it's not really important that you know everything about this. It's just I'm using a SQL query to get at the data, and the first thing that I'm going to do is on this 147 million lines, I'll just count them. How quick will that be? It's not going to be really quick. It's still going to take 3.6 seconds to count all the rows. But again, that would get you to 2 minutes on a local database, even with best hardware that you can buy. Then I can do an average of the children's weight. So weight pounds, I think, yes. So now it's gonna go out and count the weights of the 147 million children and then do an average of that. And it takes its time, but it's still 4.4 seconds. Again, that would like take a lot of time on a local database. Now you might be thinking, yeah, well, nice, but I can always do this on a local database. It's just gonna take more time. That's it. It's not gonna be. This is not really revolutionary. This is just faster. Well, I think this is pretty revolutionary because now it totally changes the way that you work with data, because now you don't need to go to grab a cup of coffee every time you run a query. You don't need to be afraid of 141 million rows. You just go there and you just start using it, right? And you start experimenting. So let's do the sum of the weight of all the children. So we're now counting the. Okay, so now we have the sum of all the newborns. Let me actually. I want to know what it is. So pounds in. So okay, now you know that in the last couple of decades, 456 million kilograms of children were born in in the US, and stuff like that. Now let me switch to the grand finale here. This is the query that probably. Again, it's really stupid, but it's very maximalistic, as you can see. This query goes to 120 million measurements of weather data. It gets the data, it groups them by month, I think, by month. Then it gets the average of all those in a given month in the US. Then it gets that table and merges that table with the natalities that you just saw, with the childbirths, and it attaches the temperature to all the childs that were born. So you know that this child was born in a month that had this average temperature in the US. Then it actually sorts all those by the weight of those children, and then it outputs the top of it, the top 10,000 children, right? So, okay, I hear the tension in the room. Will this work? Is it dangerous or? But let's do it. This will take some time, right? This would be impossible to do on a local database. Just impossible, I think. I've never tried it, but it's gonna take some time. The real deal here is that this is not just one supercomputer doing the computation. This is actually maybe tens, maybe hundreds of computers slicing the query into little pieces and working on those little pieces independently, then talking to each other and having the result, arrived to where we are. Still working, 140 million rows, 120 other million rows, counting and averaging everything, and then sorting everything inside. And now this, yeah, okay, nice. So we have the fattest boy in US was born in 2007, and the average temperature in Fahrenheit, of course, was this. Okay, and that's a table that I can actually download and work with. So that's BigQuery, and I think that's pretty. That's something that works well. The thing that full disclosure here, BigQuery is a paid product. It's not free. You have to input your billing information to start using it. The fortunate thing, or fortunately, there is a free quota to use it, and that's 10,000 queries per day that you can use. And so we've just done 3 queries. We could do another almost 10,000 queries this day, and we're still fine. We don't need to pay for this. But it's fair to say that if you did do 10,000 queries per day, you would have to pay. Now, why would anyone do that? Because you might be trying to introduce this BigQuery as your API, as a backend of a web page, for example, so that people don't need to use this horrible language, but they can actually click and see the data themselves in a user-friendly manner. So this is BigQuery. Now, another a little bit user-friendlier thing, as what I've talked about before, is Google FusionTables. Now, I've told you that there's a lot of FusionTables out there already about everything, including fishery. Now, I want to show you how that works. So let's say I have a table already here. It's a table that includes almost all the countries in the world, and a lot of data about them. These are indexes. This is just the first part up to G. So that's a lot of data. And I want to analyze it, I want to slice and dice it. And more importantly, I probably want to merge it with something else. So let's look at the map now. So FusionTables is clever enough, let's say, that it sees the countries here. So it geocodes the countries and says where on the map that is. So if I click on the map, I can see all the information like this. So if I want to know about Germany, I can click on the thing that's in Germany, right? But this is not really helpful, because this could be helpful if this was something happening around a small area in Prague, for example, and then the dots would make sense. But in this case, because it's about the whole country, we don't really like the dots, because Russia is somewhere here. That's not helpful. So let's merge this table with the actual boundary data of all all the countries that we're talking about. And in FusionTables, it's called FusionTables because merging is really simple here. I could just find another FusionTable and merge, or I can actually have FusionTable find that other table for me. So I click Find a Table to merge with, and I will try to merge according to country code. And let's say I want boundaries. Yep. So this looks like a nice FusionTable with the world boundaries. I click Next. I say which which column to merge against or on. I select what kind of table I want to get. For the sake of clarity, I'll just pick a few. So actually, let's do, what can we, organized crime, nice. And then the geometry. So we'll have a table of those two tables that has the geometry of the countries and the organized crime score of that country. And it works, and we have a merge table. The nice thing about the merge table is that it updates according to the table that it merges from. So if I did anything with the boundaries, or if I updated the crime rates in the original table, it would automatically, under a second, it would update in the table that is merged from it. So you don't need to really worry about updates or anything like that. And here's the table, and if I click on the map geometry, and so you can see that I have the nice boundaries now. But this is still not good enough. This just tells me what countries I have data for. But fortunately, I can actually style the map according to one of the things that I have there. So let's show a gradient of the organized crime, and I know that 0 is worst and 10 is okay, or no crime. So I'll put red for the most, dangerous ones. Hopefully that'll work. Come on. Oh, sorry. 10 is the most, not 100. Oh yeah, that looks better. So now I have a map that I can interact with. There's all the data. I can see that Italy has obviously some problems with organized crimes, but I can also see the context, right? So I can see that Slovakia, for example, is a little bit reddish, and Austria is awesome. There's no organized crime there. So okay. So that's FusionTables, really, really good. A lot of FusionTables are already there, and you can merge with them really easily. Now, data sharing, and that's the last part of what I'll be talking about. What if you have this nice map and you want to share it somehow? Or what if you have this nice table and you want to share it? So obviously, one thing is FusionTables. If you've done the last step in FusionTables, like we did, you can just click on here. You can do publish, and you publish this site for everyone to see, and you can actually, paste it into your website so that everyone can look at it, everyone can interact with it, and so on and so forth. This has been done by something that we've already seen here. Guardian's data block is doing this a lot. So they always have some FusionTables, and this is just a FusionTable up here, right here, that gets the poverty data from the UK, and it gets the data of the rioters of the recent, or not so recent, strikes in the UK, and it just gets their home addresses there. So of course you don't really know who that is or the exact address, but it grabs how, and it shows nicely that it's a myth that the people who were rioting in London, for example, were some bored upper class kids. They were really from the poverty-stricken. And the nice thing about FusionTables is that you can really interact with it. You can go here, you can see all the cities, you can zoom in. So it makes it really easy for the citizens to actually look at and input their own stories into this whole mess. And you're probably, if you're from the UK, you would check your neighborhood, you would check your friends' neighborhoods, and so on and so forth. Really easy, and again, this data is a FusionTable, so you can actually look at it. If you're interested, you can go inside the data and merge it with whatever you have. Something really even simpler here, and I want to mention it, is what the guys here in Czech Republic in the iHned data block did, was just getting David Rath, who's a politician here, of speech in the parliamentary room, and just saying, okay, let's look at the speech and see what he said wrong, what he said right, if anything, what are the facts there, and so on and so forth. So really, this was really simple, because as you can see, they just did an embed with the speech and let anyone comment on it. And as you can see, because it's so easy to actually type a comment, I can type a comment right now here. People did this, and they were really interested in this and started commenting on everything. And it's not just blabbering; it's not just simple platitudes. It's really, okay, how can we look at this? Is this really right? And so on and so forth. And they did it just by embedding the thing there and doing nothing else. And this for me is the next level of interactive data, because now it's not interactive in a way that you can zoom in and zoom out and change colors or whatever. You can actually put your stories and put your opinions into the data and commenting with the other people, and that data, that your input stays there for everyone to see. Okay. So with that, I'd like to thank you for your attention. I hope this was at least a bit informative for you. And if you have any questions, I don't know if we have time for questions. Thanks.
Yes, we have time for questions indeed. So are there any questions from the audience?
Thanks. I have one little technical question. If I publish a set of data in FusionTables on a website, embed in embed code, is possible to implement a search in it?
I don't think so. No. You can always say, go to that table and search there, but you can't. I don't think you can search in the embed. No, sorry.
Okay, thanks.
Any other questions?
Oh, by the way, if there are any government officials here who would want to put, or if you know any, and if you know they would like to put their data in the public data explorer that I showed earlier, I have a process for you. I have a form that you can fill in. So just ask me afterwards.
Yeah, that's great to hear. So any public officials having some data to be imported in the Google Public Data Explorer? No? Let's see. Do we have any other questions before the lunch break? Here's one.
Just a very small question. You mentioned that the BigQuery is paid. But the first 10,000 queries are free.
Yeah,
they are not constrained with the size of the table. So it should be huge tables like yours.
You can do huge queries. Okay. Yeah, 10,000 a day. Yeah.
Okay, thanks.
Okay, let's close this. I have actually one final question for you. Does Google actually use these tools for their own needs? Do they use them for their own infrastructure?
The BigQuery? Yes, definitely.
BigQuery, Refine, or anything else?
Refine, I don't think so. Refine was actually, it's not a Google invention. It was bought with Freebase, yes. The BigQuery it's mostly based on tools that we use internally. So there's needs to be another. You can see that Refine is not really nice. It's not really user friendly yet. This is what we use internally. This kind of, it's not polished, I'd say, right? Whereas this one, this is kind of polished. So yeah, it's closer to what we use internally. But
okay, thanks for answering. It's good to hear that these tools are even good enough for Google, so they must be good enough for us to use. And with that, I would like to close the first section, the first section of the Big Clean. And I would invite you for our rather experimental lunch in the foyer.